just jump on there. So can you see my screen now or no?
Yes, I can see it.
Okay.
Wait. Oh, okay.
So
Yeah.
yeah, go ahead.
Can I go grab a piece of paper real quick so I can like write it down?
You don't need to write it down. Just watch. Okay. You just
Okay.
watch, and then you can. This is all recorded, so you can watch it again later
Oh, okay.
if you need help or look at it again later. Okay.
Yes, sir.
So we're gonna start with the first one up here. It says if OMG is an acute angle and the measure is that, find the restrictions on X. So acute means that what is OMG between?
It's between 0 and 90. Like it has to be more than zero and
Good.
less than 90.
Very good. So it's got to be less than 90, but it's got to be bigger than zero. We'll just call X. We'll call X OMG, right? So X
Yes.
has to be between 0 and 90. And I don't think they want you to say zero because then it would just be no angle, right? And they don't want you to say 90 because then it'd be a right angle. So that wouldn't be acute. So it says
Yes.
if whoops, sorry, I shouldn't have put X in there. I should have put the expression for the angle, which is what they tell
Six,
you the angle was.
6x plus 5.
Good. So 6X plus 5 is going to go in the middle there, right? So all I have to do is solve for X now. So this is called a compound inequality. I'm treating it as two different equations. I'll do this one in blue. So first I'm going to subtract 5 from that side, and then I'm going to divide that side by 6. So negative 5, 6. So X has to be bigger than negative 5, 6. But I also can do this side, in which case 6X has to be less than, I'm subtracting 5 from both sides, right?
Yes, sir.
85, which means 6X has to be, or sorry, X has to be less than 85 over 6. And 85 is not divisible by 6, by 3 or 2. So I can't really reduce that. So there's
Yes,
your
sir.
answer.
Oh, okay.
Okay. So you're treating it like two different equations, two different inequalities, that inequality and that inequality. Does
Yes, sir.
that make sense?
Yes, sir.
Questions about it, or you understand that now?
Um, yes, sir. I understand. I understand.
You get that? Okay. Then later maybe you can show me what you did. Okay. So I can see how
Yes,
you
sir.
would have thought through that problem. Number 10 says the sum of a leg and hypotenuse. So leg means one of the shorter sides, right? So either this side or this side is the leg. Can you see my
Yes,
little
yes, sir.
little circle? Okay. The sum of a leg and a hypotenuse, so the hypotenuse is the longer side, the side across from the 90-degree angle, is that many meters. If the other leg of the triangle has a length of 5, what is the length of the hypotenuse? So what we're doing here, let's ignore this, but let's just come up with it on our own. So we're going to first draw a right triangle, and we know that right triangle, we know one of the legs is 5 because that's what it said. It said one of them has a length of 5, and we
Yes,
know the
sir.
hypotenuse and the leg, the hypotenuse, the sum of a leg and the hypotenuse of a right triangle is 15. It says the other leg is 5. So this is the one right here that adds to this to make 15. Right? Do you understand that what they're saying?
It's so.
So
Oh,
what we're going
yes,
to do
sir.
is, yeah, so we're going to call this the hypotenuse because that's saying what is the length of the hypotenuse. So let's call that H. So if that's the length of the hypotenuse, we know that when you add that to this one right here, let's call this right now, I don't know, L, right? You know that it says the other leg has a length, sorry, not the other leg. It says the sum of a leg, it was a leg. We're looking at the blue leg, right? And the hypotenuse is 15. So we know that L plus H equals 15.
Yes, sir.
You get what I'm saying? So
Yes.
what does this thing equal? It equals 15 minus H. That's what that side, we
Um,
could we could write that side as 15 minus H instead of naming it as L. We're going to name it as 15 minus H.
yes, sir.
It makes sense. That's the hardest part, is figuring out how we got that. And now we're just using, or we're using Pythagorean's theorem to solve this equation. So Pythagorean's theorem, remember what that says?
A
Says that
squared plus B squared equals C squared.
the sum of the two sides squared equals the
Yeah.
hypotenuse squared.
Okay.
Now it's an algebra problem.
Yes, sir.
That's why I was asking you earlier, how good is your algebra?
Oh, I mean, it's all
Do
right,
you know
but
how? Because that could be the problem. That could be the problem that you're having, is you're just making algebra mistakes. So how
yes,
do
sir.
I solve this equation?
Um, you got to,
Tell me what to do first.
uh, you gotta square the parentheses.
Okay. And how do I do that? Tell me what 15 minus h squared would equal.
15 minus h times 15 minus h
Very good. Very good.
would
So you can't just square each one of them, right? You got to multiply it by itself, right? And
yes,
what
sir.
does that equal?
It equals
15 times 15 is 225,
220.
right?
Yes,
So
sir.
it's 225 minus 15h minus another 15h plus h squared, right?
Yes, sir.
See how I did that? So that
Yes,
would
sir.
be 225 minus 30h plus h squared, yeah?
Yes, sir. It would.
So let's write that in. 225 minus 30h plus h squared equals h squared. And then 5 squared is, of course, 25. So these add together and make 250 minus 30h. And what happens to the h squareds on both sides?
They cancel each other out.
Yeah, because you can subtract it from both sides, right?
Yes,
So
sir.
equals 0. Now, how do I solve this equation now?
You subtract 250 on both sides.
Good. And then what?
Then you divide 30 on both sides.
Good. And notice what I can do, that would just become positive. The tens would cancel out. So it's just 25 over 3, which doesn't reduce anymore. So there's your answer.
Okay. What she got on the thing was 8, and then 8, like, and then one third.
Yeah,
One third.
you can reduce it. Yeah, you can reduce it if they said write it as a mixed number. So how many times is 3 going to 25?
8,
8 times. And what's left over?
one third.
Yeah, one's left over. So 1/3, 8 and 1/3 is the same thing. You can write it either way.
Yes, sir.
Just depends on what they want, how they want you to write. Okay, good with that one.
Yes, sir.
Okay, so next says given angle 1 and angle 2 are congruent, the measure of angle ABC is 90. Angle 1 is that expression, angle 2 is that expression, angle 3 is that expression. Find the measure of angle 3. So we know that 1 and 2 are equal to each other, right? So that equals that. So we're going to first start by writing that equation. Negative 3x plus 2 equals y minus 3.
Yes, sir. That's what I did.
Okay, that's the first step. And then they also said that measure of angle ABC is 90. Oh, they already gave us this picture. ABC. So all of these add up to 90. 1 plus 2 plus 3 adds up to 90.
Yes, sir.
Does that make sense? So negative 3x plus 2 plus y minus 3 plus x plus y plus 1.
Equals
All of
90.
those add up together to 90. Yep. So what we have now is two equations with two variables. That's called a system of equations. And so we can clean this up and we can solve for one variable and then substitute that in for the other variable. Do you remember doing this in algebra?
Yes, sir.
Okay. So first step, depends on how you want to solve it, but the first thing I would do is just clean both of the equations up. So this first equation Let's just move the x's or the variables to one side and the non-variables to the other side, putting them in standard form. So
Yes.
3x minus y. See how I subtracted y?
Yes, sir.
And let's move the 2 to the other side. So what would I get if I move the 2 to the other side?
-5.
Perfect. Good job. Now let's clean up the second equation. I'll make that one red. So let's keep the x's on this side. How many x's do I have?
You got 2.
Good. So what would the answer? How many x's would I have?
Uh, just 1.
Add your like terms, right? Here's 1x.
Yes, sir.
Negative 3x plus x. What's negative 3x plus x?
-2x.
Good. Negative 2x. And how many y's do I have?
You got 2.
Yep, positive 2y's, right?
Yes, sir.
And then on the right hand side, let's move all the numbers over to the right hand side. So I've got 2 minus 3, that's a -1 plus 1. Oh, that's just 0. It's all gone.
Yes, sir.
Got it?
Yes, sir.
So there we go. So doesn't that look a little bit easier to deal with? Does that look familiar to you now?
Yes, sir. I got that.
And now you know what to do? Remember how to
Yes, sir.
solve this?
Um, no, that's kind of where I don't get it. Like I could get to that point, but I didn't know where to go next.
Okay. So since we have this in what's called standard form, is we're going to do what's called eliminating a variable. And the easiest variable to eliminate is the y. The reason that's the easiest to eliminate is take a look at them. You see how this is +2 and this is -1.
Yes, sir.
So if I multiply this entire equation, that first equation, if I multiply that entire first equation by 2, multiply it by 2, that equation would be -6x minus 2y equals -10, right? So I rewrote that equation like that. And the reason I would want to do that is because now if I add these equations straight down, what happens to my y's?
They cancel out.
Yeah, they get what's called eliminated. They get
Yes, sir.
eliminated. That's why it's called elimination, right? So add everything together, you're going to get -8x. You're going to get 0y, so don't have to write anything, equals 80. So now what does x equal?
X equals -10.
Perfect. And if x is -10, you can put that all the way back up in that first equation and find out what y equals. So let's plug it in. -3, I'm plugging in -10 for the x in that top equation, plus 2 equals y minus 3. Got it?
Yes, sir.
And then what would that equal? 30 plus 2 equals y minus 3. So 32 equals y minus 3. So 35 equals y.
Yes, sir.
There are your two answers. X is -10, y is 35.
And you would have to find measure 3, so you just put in
Oh, sorry.
-10.
Yeah. Yep, very good. So then it said find the angle of, or the measure of angle 3. So that's 25 plus 1, which is 26.
Yes, sir.
That's the right answer. Looks like it is.
Yes, sir.
Okay, good.
Yes, sir.
Awesome. All right. Sorry, hold on. My daughter's home. Hey, I'm tutoring, hon. That's okay. All right. Last one. Say in problem 4 through 6, determine if the statement is always, sometimes, or never true. Make sure to justify. So the intersection between line A and segment AB is a ray. The intersection, nope, it is never true because the intersection is just the ray.
Yes, sir.
The
I'm just kind of
intersection,
sorry.
it's okay. So
Uh, I'm just
go ahead.
I'm just kind of confused on like all the words. Like, I mean, I know what kind of array, kind of what array
Uh-huh.
is, and kind of what a segment is, but like sometimes I forget.
Okay. Yeah, sure. So this is definitions. Definitions are important. Array as a point at one end and an arrow at the other. That's a ray. A
Yes.
segment has a point on both ends. It ends at both ends. And a line, so this is a segment, and a line has arrows on both ends.
Yes, sir.
So if you have a line AB, go ahead and draw your line AB. A is here, B is here. That's called your line AB. And then the segment would be this red piece right here. That's the segment. So what's the intersection of that black line and that red segment?
AB.
It's just the segment. That's right. It's
Oh,
not a ray, it's a segment.
okay.
So the overlap is just AB. So it's never true that it's the ray. Okay.
Okay.
Number 5 says MNL is the same as LMN. So let's draw it out. LMN means you start, or NML. The definition is this is always the vertex. The middle point or the middle letter is always the vertex. Got
Yes,
it?
sir.
So what's the vertex for both of these?
M.
Yeah. And does it matter which side you start on? Does it matter if you start on N or if you
No,
start on
sir.
L? Does that really matter?
No,
It
sir.
doesn't matter, right? It doesn't matter. So what's the answer? The answer is always. It's always true that they are the same. Okay.
Yes, sir.
Number 6 says if there is betweenness among points, that means um, um, I don't actually know the definition of betweenness. Do you have that definition?
It's in my notebook. Well, my notebook is in my backpack. That's downstairs.
I don't know what they mean by betweenness. Let's see if I can find
Um,
it.
I think it's just like what's between the points.
Yeah, but what does that mean?
No.
Betweenness. Okay, betweenness.
Go ahead, shape it.
Betweenness. The quality of state of being between two others in an ordered mathematical set. Well, that doesn't really help me. Betweenness in geometry is what I want. Betweenness in definition geometry. Here we go. Betweenness of points. By definition, a point B is between two other points A and C if all 3 points are collinear and AB plus BC equals AC. So betweenness is betweenness implies collinearity, meaning they're both on the same line.
Okay, so that's just like
See, the reason I had to ask that question is because the definition of betweenness could have been here's point A and here's point C, and this is point B. Is point B between A and C?
no, sir.
Well, that's what I'm saying. I don't know what the definition. It depends on your
Um,
definition of betweenness. If you're
the
thinking
thing
of
is,
point A being like this and point C being like this, then B is between them. But
but
but if you're
it doesn't
talking
matter.
about between on a line, then they're not between. Then then it's
Oh,
different.
oh, she was talking about that in class the other day, and I didn't really get it.
Yeah. So that's why I had to know what the definition was of betweenness. That's not a phrase that I've really heard used. So you just
Yes.
have to ask, well, what's your definition of betweenness? According to what we just looked at, betweenness does mean that's collinearity. So it says if there's betweenness among points, there's also collinearity. The answer would be yes, because the definition of betweenness involves collinearity, meaning they have to be on the same between betweenness means that you have to draw a line, and on that line you have to put point B. Now
Yes,
I
sir.
can say there's betweenness between those for those points.
Yes,
Okay.
sir.
So that's why this is always, because that's actually the definition of betweenness.
All right. Yes, sir.
That makes sense to you?
Yes, sir.
All right. Do we have some more we can do?
Um,
More problems that you need help with, or other things that we can talk through? Because that was all of that.
I'm trying to think. 'Cause I have papers, but I don't know which ones I need help with. So I'm sorry. Look,
That's right. Go ahead and look through your stuff, and I'll give you control again over the screen, and I'll um let me stop the stream.